Today in class we started talking about parabolas in a slightly different way than we have before. Parabolas just for the shape of them themselves, not as something that represents a quadratic equation. So in this case, we could talk about parabolas that go up and down, open up and down, or left and right. And we're talking about them in terms of what part of a cone they are, or basically talking about them as a part of a cone, as a representation of a type of cross section you could take of a cone. So conic sections, parabolas, we did 3 examples in class. We didn't maybe finish completely the third one, so I'm going to go ahead and go back over that one. Third one here says, find the standard form equation for the parabola with a focus at -6, 4. So -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Here it is. That's the focus. And a directrix at x equals 2. So that's 2 to the right. Remember that x equals is always a vertical line, up and down, because it means the set of all points that have an x value of 2. All right, so we know that this is remember my analogy, I think I used 5th period, I didn't use as much 4th period. This is like a baby bear. The vertex is mama bear, and she's keeping him from going off a cliff. That's my directrix. The directrix is a cliff. So mama bear has to be exactly in between the baby bear and the cliff. So the vertex is exactly in between, right in the middle, between the focus and the directrix. Why don't we use the midpoint formula then? Because you can't use the midpoint formula when you don't have 2 points. This is a point and a line, not 2 points. But so, I mean, you kind of could if you, there's ways you could do it. But basically, you would have to tweak it. So pretty much we have to think about how far apart these are. This is at -6, 4. Now, moving from the focus to the directrix and or to the vertex in between them, we're going left and right. That means we're moving the x values. So looking at this x value of -6 and this x value of 2, even if you didn't have a grid to count things off, you could figure out how far it is from -6 to 2, and that's 8. Or figure out what the middle number is between -6 and 2, just like you're doing midpoint formula. -6 plus 2 divided by 2, that's going to be -2. This is where the vertex is, at -2, 4. It's on the same, it's right here between the focus and the directrix, so it's on that axis of symmetry that runs perpendicular to the directrix. So this is my parabola. And again, I'm just talking at this point about basic parabola shape. It's a U in terms of only looking at which way does this open. So it opens to the left. So now I'm trying to figure out this equation. I have the vertex, it's -2, 4. That is my h and my k. The next thing I need to figure out is which equation. This is opening left and right, so it's one of the ones that's going to start with x. You've got 2 options here. Basically, things that open left and right, it starts with x, and then y is the squared part. If it opens up and down, it starts with y, and then x is the squared part. So this is going to be x minus h equals 1 over 4p, y minus k, quantity squared. Okay, so x minus h minus a -2, that's going to be plus 2, minus a 4. The next thing is p. P is the distance from the vertex to the focus. It's really also the distance from the vertex to the directrix. Remember, the mama bear is exactly in the middle. So these 2 distances are the same. This part here and this part here. But in terms of the sign of P, we can think of it as getting from mama bear to the cub. How far it is, or how to get from mama bear to the cub. So if we're going left, that's -4 to go from the mama bear to the cub. So basically it's always from the vertex to the focus if you want to think about what the sign is. If you have to go left or down to go from the vertex to the focus, your P is negative. Or this part is going to be negative. If you have to go right or up to go from the vertex to the focus, then it's opening upward, and this part would be positive. So in this particular case, P is -2, or we're going to have a negative here, so you could think of it as plugging in a -2, or you could just think of it as 2 and recognize that this whole part is going to be negative. So 1 over 4p becomes 1 over 8, but it's negative. So make sure it does make sense to you. If it has a negative after the equal sign, that means it opens left or down. If it has a positive after the equal sign, it's opening right or up. Next, example 4. Find the standard form equation for the parabola with a focus at 6, 2. This is this problem right here. And a vertex at 3, 2. Again, you should be able to figure it out both from a graph in terms of counting off marks to the right and to the left, and also in terms of numerically. So this is 1, 2, 3, 4, 5, 6, 1, 2, 6, 2. That's the focus. And the vertex is at 3, 2. Okay, so we're talking about a parabola that opens like this. So from 3, 2 to 6, 2, look at what changes. The only thing that changes is the x value. So we're moving back and forth on left and right in terms of on the axis of symmetry. Both the vertex and the focus are always on the axis of symmetry together. So that's why they have the same either x or y value. If they're opening left and right, they have the same y value. Okay, so from 3 to 6, that tells me the mama bear would have to go 3 to the right to get to the baby bear. So P is positive 3. It's also positive. We can also tell that it's positive because it's opening to the right. This is my H and my K. So now I have everything I need. Because it's opening left-right, it's an x equals, and y will be the squared. X minus H equals 1 over 4P becomes 1 over 4 times 3. Y minus 2, all quantity squared. It does not ask me for the directrix on this one, but the directrix would be 3 the other direction, so that would be right here, which is the y-axis. It's important to understand that the equation of the y-axis is what? X equals 0. Vertical lines always have equations x equals some number because they are the set of all points where the x value is the same. Next, example 5. Find the vertex, focus, and directrix for, and it gives me the equation. So let's go ahead and analyze the equation it gives me. X minus 2 equals 1/8 y plus 1 squared. It's quantity squared, I should say. Now, the format here is this format. It starts with x, and the y part is the part that's squared. So that's opening left and right. So that's the first thing I know, is it's opening left and right. The next thing I know is because this is a positive number right after the equal sign, that left and right becomes just a right. It's opening to the right. So we now know that this is a right opening parabola. You might want to make a note of that. We also know that the vertex is 2, -1. The next thing we need to find from this equation, just like to write an equation you need two things, you need to pull two things out. You need to pull the vertex and you need to pull P out. This part, whatever's between the equal sign and the binomial squared, is always equal to 1 over 4P, whether it's a fraction or not. So whatever's here, we set equal to 1 over 4P. This time it's pretty easy to see how those would work, because 1 over 8 equals 1 over 4P means that 4P must be 8 and P is 2. Okay, so now we know that to get from the vertex to the focus, we're going to go 2 to the right. Now looking back here, I'm going to do the rest of this one without the graph for a second, just to point out that you don't really need the graph to be able to do it once you understand where you're going. You do have, it does help to kind of have some idea of, like I've told you, you might want to sketch it even if you're not looking at a graph. Just to think about, okay, this is at 2, -1, and I'm going to go to the right 2. If you are moving to the right from the vertex, it's the x that's going to change. So right here where it says FH plus P, if I'm moving to the right, I'm basically adding P to my vertex, and my focus is at 4, -1. Okay, the directrix is the opposite direction. That's why it says directrix x h minus P. So here's h, take 2 away from that, and my directrix is 2 in the opposite direction. That's x equals 0 again. So x equals 0 is my directrix. Don't just put 0. It's not a line if you just put 0. That's just a number. You have to make sure when you're talking about vertical and horizontal lines, axis of symmetry, any of those things, that you say x equals or y equals, depending on which one you're looking at. And I guess there's nothing else they asked me for there. So that would be that. Example 6 gets a little bit more interesting. Now here's your graph for that one. That's what the graph would look like. Again, on my parabola here, I'm not being super accurate with the parabola at all. I'm not implying the parabola goes through those points. I'm saying that it opens to the right, and that's all. Just drawing a very generic looking U. All right, number 6. Example 6. It says, find the vertex, focus, and directrix for, and it gives me one that clearly opens up and down because it's in this form. Don't forget that when the x and the y swap, so do the h and the k. K always stays with y, h always stays with x. So in this case, my k is 4 and my h is 1, so my vertex is 1, 4. Then the next thing is, at the beginning of the equation, this is what you see, or excuse me, at the beginning of the right side here. This is what you see. Remember what I said, that whatever comes between equals and the binomial squared, this equals 1 over 4p. So what is that? It's a negative. Okay, so what would I just put equals negative? No, that doesn't make any sense. It's negative 1. If you just have a negative, that's the same thing as negative 1 times. So 1 over 4p equals negative 1. If you have a fraction equals a number that's not a fraction, it makes a little bit more sense to go ahead and make it a fraction, and now we can cross multiply. So 1 times 1 equals negative 1 times 4p. Divide both sides by negative 4, and p is negative 1/4. So this is what we know so far. Now, we also know, remember, that it opens up or down. Which one? Down, because there's a negative right after the equal sign. So this is opening down. Okay, so again, just sort of analyzing my coordinates rather than looking at the graph. And you can look at the graph too, but I want you to be able to do it both ways. If I start with a vertex that is 1, 4, and I am moving down from that 1/4 to get to my focus, then what changes when you go up and down? The y, not the x. So the y is going to go down by 1/4. So you could say it's this. Fractions are probably better, but that would be 3 1/4, or even better yet, that would be 15/4. Okay, but I just wanted you to see, if I'm subtracting, I'm going down, I'm subtracting from the y. The y is moving down, it's subtracting. And I figured decimals might be the easiest one to see that with. So this is like my minus 1/4 happening. If I'm going to go, if the focus is down from the vertex, here's the vertex, here's the focus, the directrix is up from the vertex. So I need to add to the 4. I need to move up from 4. So my directrix is at y equals 4 and 1/4. Add 1/4, or 4.25. I'd be okay with that on this. Okay, so 4 1/4, 4.25, or 17/4. Any of those is fine. It's really hard to graph this. I just kind of crammed it in there, and it's obvious that it's not accurate because you can't graph it on this particular grid accurately because it's hard to show quarters. You'd have to make a better grid. Okay, but there's what my graph looks like. Next, I finally get to do something really exciting. I get to put it in that, what we've been calling conic form. Technically, that's not general conic form formally, but it's the form we like to have it in when we're doing conics, which is basically just like vertex form, remember, with that extra number moved over so that there's not just an extra number at the end. And in this case, my a is referred to as 1 over 4p. But that's basically that form. Okay, so graph the parabola and label the vertex, focus, and directrix. So here's my parabola. The first thing I have to figure out is which format this parabola is supposed to end up in. Remember how we used the format that the circle was supposed to end in to help us figure out how to get it there. So I have to figure out, what am I trying to move toward here? What do I want it to end up looking like? Well, there's only two options. It's either going to look like this one or this one. And the easiest way to tell which one is by telling what's squared. Y is squared. Okay? Up and down, the y is not squared and the x is. left and right, the x is not squared and the y is. So this is going to look like this. The y is the squared variable, so it's going to end up looking like this. So this is what I'm trying to head toward. Okay, so getting there, first thing I'm going to do is I'm going to leave my x terms on the left. And I'm going to go ahead and leave any plain numbers on the left as well. Okay, so I've got 8x plus 8, and I've got to move those y terms over to the other side. So equals, this is a negative y squared now and a positive 8y. We don't complete the square if there's anything in front of our variable that's squared, meaning we factor it out if there is. We don't start completing the square until we've done that. So I'm going to do this. Negative, that's y squared minus 8y, plus, and we're going to have to complete the square in there. Well, if I'm going to add something over here, I need to add it over here as well. So I've got to put a blank on both sides. Now, don't worry about the 1 over 4p. That will happen by itself. Okay? Worry about getting the square part squared and move the x's and numbers over to the left while you do it, and make sure you keep it balanced. So this is going to be half of negative 8 is negative 4. Square that, you get 16. Except what's just happened, I got to be very careful about. By putting a positive 16 here, I have really added a negative 16 to the right. So if I added a negative 16 to the right, I need a negative 16 on the left as well. Because of this negative out front, putting a 16 here did not add 16. It really subtracted 16. So I'm going to do it over here as well. So over here now I have 8x minus 8. And over here I have that negative 1 still. And this is y minus 4 quantity squared. Okay? Now, in the final format here that we've been trying to go for, there's no number in front of x. So we don't want a number in front of x. This is where things work out with that 4p. I'm going to divide both sides by 8 to get rid of whatever number's in front of x. Dividing both sides by 8, really I could just do 1 over 8. I don't have to divide, I don't have to show it all the way across, because it's negative 1 over 8 times all of this. So x minus 1 equals negative 1/8 y minus 4 squared. That is my vertex form, or excuse me, it's my conic form really. That's my parabola. And now I can look at what I've got here. I've got a vertex of 1, 4. If 1 over 4p equals negative 1 over 8, I would go ahead and put that negative in the denominator and say then p must equal negative 2. Now which way is this opening? Remember, here's your equation. It's opening to the left. So it looks like this. You have your vertex. P is negative 2 means my x value is going to go down by 2. So here's my focus. Okay. So go the opposite way to get to the directrix, and that would be adding 2. So the directrix is at x equals 3. And that's my info.